Okay, for this video, we'll be doing your dynamics notes C4. Okay, so you should have this question with you. Okay, let's start. The figure shows the variation with time. So this is time of a net force. So this is actually F net. Okay, so this force is actually F net, which is acting on an object. Okay, so this is F net, and we see that from time 0 all the way to time t, we have this constant value of F net. So from 0 to t, we have constant F net. So whenever we have F net, what do we think of? There will be, because there is F net equals to ma, okay, since there is F net, a constant value, therefore we will have constant acceleration, right? So this is Newton's second law. Okay, so now we are asked to choose which graph correctly shows the variation of the velocity with time. So we are all dealing with VT graph. So for VT graph, we know that the gradient represents acceleration. Okay, so how do we link all this? From time 0 to t, which is shown from here, 0 to t, we see that there is constant acceleration. When there's constant acceleration, it means that the velocity increases at a constant rate. Okay, at a constant rate. Therefore, A is out because it didn't increase with a constant rate. It increased with a increasing rate, gentle to steep. So B will be correct, C is incorrect also, D will be correct. Okay, but after that we see that for the next part after T, okay, F net equals to 0. When F net equals to 0, it also means that acceleration is 0, but because the object was already moving, so it will then move with constant velocity, which means the answer is B, where we have constant velocity. Okay, let's go to the next question, which is C5. Okay, I think we shouldn't do C5 first because there isn't a lot of numbers. Let's do C6. Okay, a force F pulls two blocks connected by a string. So this is the pulling force. Okay, so the two blocks are connected with a string. Now the way to do this question is treat the two blocks as one object. Okay, the rationale is very simple. Imagine they are pulling something like that. You would just think of them as a combined mass of 8 kg. So let me draw the free body diagram. It is as if your force F is pulling a block of 8 kg, right? 8 kg. So if I know that there is no friction, okay, because it's a smooth surface, then this pulling force F actually becomes the F net, right? Because in the horizontal direction, there is only this pulling force. There is no friction. No friction, yeah? Okay, then we also see that there is an acceleration of 2 meters per second square. That means each individual block will have the same acceleration, right? Imagine you're in a MRT train and we have two carriages. One have a lot of people, one is empty. Okay, is empty, so it is being pulled along by the engine force. Will both carriages actually have the same acceleration? They must have, right? If not, then the carriages will be knocking into one another. Okay, so they both have an acceleration of 2 meters per second square, 2 meters per second square, which means if I treat this as one whole object, then with this 8 kg mass, it will be moving with acceleration of 2 meters per second square. Okay, so whenever there's acceleration, there's going to be F net. So I can actually do my calculation. 8 times acceleration, 8 kg times acceleration, I'll get 16 Newton. Okay, so this is important. That means I would have B and D as the correct answer because I have F equals to 16, F equals to 16. Okay, but how do we find this tension force? Okay, so in order to find the tension force or the force acting between these two blocks, I would actually need to separate them. So before that, I treat them as one object just so that I can find my Fnet. But now I actually have to break it up. So I will have to draw two free body diagram. I have a 5 kg mass. Okay, it is being pulled along by this force. I also have a 3 kg mass. It is being pulled along by F. And now I know F is 16 Newton. Okay, so imagine you are 3 kg. You are being pulled to the right by the 16 Newton. You are also pulled to the left by the 5 kg. Yeah, because you are dragging it. So this is due to Newton's third law, right? The 3 kg pull the 5 kg, but the 5 kg also pull the 3 kg. So let's just call this T, and this is also T. All right. So are there any other forces acting on the 5 kg? Only the T, right? Would the 5 kg know that this force is pulling him? Would he know that this force is pulling him? He wouldn't know because he will only see the force exerted by the 3 kg. Okay, so we also know that the acceleration of the 5 kg is 2 meters per second square. And whenever there is acceleration, there will be Fnet. So Fnet equals to ma. My mass is 5, my acceleration is 2, therefore my Fnet will be 10 Newton, which means my T will be 10 Newton. That means my answer is B. But let us do a check. Okay, if T is really 10 Newton, that means the T that the 3 kg is experiencing is also 10 Newton. Okay, and if it is true, then the 3 kg will experience an Fnet of 16 minus 10, right? Because T and 16 Newton, they are in opposite direction. So you will experience a Fnet of 6 Newton to the right. Yes. Then, if there is Fnet, then there is acceleration. So I have 6 Newton. My mass is 3 kg. What is my acceleration? My acceleration is equals to 2 meters per second square, which makes sense because they say the blocks have acceleration of 2 meters per second square. So this is how you solve this kind of question. You actually first, you need to treat it as one object. So either to find Fnet or acceleration. Then after that, you need to apply free body diagram. Draw free body diagram. If there are two bodies, you need to draw two free body diagram. Okay, now let us take a look at the previous question then. Okay, so there are two blocks X and Y of masses m and 3m respectively. They are touching one another. So the force F is actually pushing X and Y together. But Y doesn't know that this force is pushing him. All Y know is that X is pushing him, right? Because he only sees X making a push on him. They are accelerated by a smooth horizontal force. Accelerated along a smooth horizontal surface. That means there are no friction by a force F. Okay, and X is actually having a mass of m, Y is 3m. So we will now actually need to treat it as one object. Okay, treat as one object. So I will redraw, and this will actually become 4m. Okay, and I have a pushing force of F. Okay, by right, I can actually say maybe the mass is 1 kg. So if m is 1, then 3m will be 3 kg. But maybe I try using just algebra, just representation. Okay, but if you want, you can actually say that m is just 1 kg, just an arbitrary number. So this will then be 3 kg. So the total mass will be 4 kg. Okay, but I don't need to do that. So now that I have already treated them as one object, and because this is frictionless, that means this is going to be my F net. The only force acting in the horizontal direction. Since it's the only force in the horizontal direction, then in the horizontal direction, this is my F net. So if I have F net, there's going to be acceleration. So my F net equals to m, because now there is 4m as a whole object. This is my acceleration. So acceleration equals to F net over 4m. Okay, but maybe I call this F net as F, because this is the only force in the horizontal direction. So I hope you get this part. Acceleration of this whole 4m object, the mass of 4m, is F over 4m. So this acceleration will be applied to both x and y, right? They must move with the same acceleration. So this is after we treat this as one object. So second step is to draw your free body diagram. That means now I have actually two bodies. So I need to draw two free body diagram. So this is my x, and this is the mass is m. Then what are the forces acting on x? There will be this force F. Okay, and because x is pushing y, then Newton's third law, x is pushing y, y will be pushing x. So I call this Fyx, which is force of y on x. Alright, then I can also draw for y. Okay, and the mass is 3m. What are the forces acting on y? It is actually only force of x on y. Force of x on y, because actually object y wouldn't be able to see this force F. It wouldn't be able to see because it is actually only being pushed by x. Okay, if you don't understand this, I can demo this in class. Yeah, do let me know. Okay, but for now, I suggest that y actually doesn't know this force F is pushing it. All he knows is that x is pushing him, and this will actually be the F net that y is experiencing. Now we also know that for y, its acceleration is F over 4m. Okay, so whenever there's acceleration, there's going to be F net. So I do F net equals ma, and I'm using y first because there's only one force, which is from x to y, and this is y's F net. So this is F xy equals to mass. In this case, for y it is 3m, and his acceleration is actually F over 4m. Okay, so m and m can cancel, so it becomes 3f over 4, which is 0.75 f. Okay, so this is the force that x exerts on y, and the answer is D. Now how do we check that what I've done is correct? So by Newton's third law, if x pushes y with 0.75 f, therefore y pushes x with 0.75 f, equal and opposite forces, and this is our Newton's third law. Okay, so let's come back to here where we have x free body diagram. So Fyx is actually equal to Fxy, right? Because of Newton's third law. So Fyx is actually 0.75 f. Okay, So in this case, the Fnet will be, the Fnet that X experience will be F minus 0.75F, because now there are two forces, this F and Fyx, which is equal to 0.75F. Okay, let me transfer this over here. I have my X, the mass is M, and this is the resultant force, F minus 0.75F. In the end, I will get 0.25F. Okay, so this is Fnet on X. Whenever there's Fnet, there will be acceleration. So it becomes 0.25 F. The mass is M. The acceleration I want to find out just to test. So then my acceleration equals to 0.25 F over M. Okay, which is actually equals to what we had calculated, right? Because 0.25 is actually 1/4 F over M, equals to F over 4M, and this coincides with what we have calculated for the acceleration. Okay, so this one is hard, this question is difficult, that's why I have two versions of it. Actually, I have the third version here. Okay, now P, Q, and R are three blocks resting on a smooth surface, so there's no friction. Okay, no friction. Okay, then we have this 30 Newton pulling force is pulling the three blocks. So now my challenge to y'all is to find T1 and T2. I'll give you a hint on what to do. First thing is treat all blocks as one object. Okay, then since you're given, then now we have one object, right? Then we have 30 Newton. So if we have this from here, then you can find that this is actually my Fnet. Then you can find the acceleration, okay, equals to a certain value. Then after that, because I have three bodies, okay, I will need to have three free body diagrams drawn. Okay, so please try and practice, because it will, if you really get it, it's not that difficult. Okay, yep, I think that will be what you need to do. Then I will actually yeah, I will actually go through this in class with y'all. Thank you.